Okay, a lot of this is reading. What did Kayla say? 68? Huh?
You have to answer the last one. It was 68, right?
Yeah, it was 68. Okay, so Madeline received the following problem. Particle moves in a straight line with a velocity v meters. That's what this guy is. I like to be extra and label it myself because I want to make sure I know that's v. Okay, so that's v right there. Meters per second. I'll even put the label right here. See, this is going to be meters per second. Okay, that's the y-axis. Meters per second. Where am I? Graphed. Where t is time in seconds. Okay, let's go ahead and put seconds right here. At time t equals 1, the particle's distance, well, that's different. This is velocity, right? At t equals 1, the particle's distance from the starting point was 2. So I don't know what the position is or the distance formula. We can say d of t is our distance. So we can say d of 1 would equal 2. So that's 1 comma 2. It's a point on the other graph that we don't see. Meters in the positive direction. So that's a positive 2. What is the particle's displacement between 1 and 6 seconds? Displacement. Now, displacement doesn't require the knowledge of where the particle currently is or anywhere else. So all you have to do to find the displacement is you have to find the integral from 1 to 6. You know, it says from 1 to 6 of velocity dt. Okay, this is displacement. This would equal displacement. Yes, good question. So it was just asked, what about the initial or the known position? This is the known position. Now, if the question said, where is the position at 6 seconds, then I would need that. I would need to add the 2 to it. But it just wants to know the displacement. This will tell you the displacement, the total displacement of the particle. Okay, so this says, which expression would Madeline use to solve the problem? Because I can't actually solve this problem. I can't do the integral of v because this is all I know about v. So it just asks for the answer here. So it wants displacement, so this one. All of these are for a different answer. This one is for total distance. This one right here is for new position. New.
Wouldn't D be?
Absolute values?
Yeah, these are absolute value bars right here. It's hard to see.
Why do you say
C is the answer.
No, C is displacement. This is displacement.
Shouldn't it have no plus 2 then?
Okay, now I know there's a lot of calculus going on here, but I want to talk really quickly about a very simple scenario to try to help you guys understand the difference between total distance and displacement and new position. Okay, so if you have a particle moving back and forth on this line, let's pretend that the particle starts at 3. Okay, and the volume, or it's not the volume, the varsity, what does this V mean? Velocity. The velocity says we move a positive distance. Let's say we move a positive distance of 4. What would be the new position?
7.
It would be at 7, right? So this is plus 4. Okay, now I want to say, now the particle moved negative 10. Okay, where's the new position? If we move negative 10 from this spot right here, because this is like when t equals 3 or something, where would we be?
-3.
We'd be at negative 3. So negative 10 would take us back this way, right? And then we would be right here at negative 3. Okay, so we have a couple of questions here. First of all, what is our displacement from the initial spot? This is the initial spot. What's our displacement? Displacement. I don't know how to spell. Okay, it is negative 6. How do we know it's negative 6? Because from 3, we ended up at negative 3. Did it take into account the positive 4 and the negative 10? Like, did we know that? Well, when you do displacement, which is just the integral, it's just going to add the negative 10 and the 4 together to give you negative 6. That's your displacement. What's the new position? New position is negative 3. Okay. What's the total distance? 14. Is 14. So this one right here, the absolute values, That would make the 10 positive and add those together to give you 14. The new position, the way you get that is you have to take the 3, and it would kind of look like this. It would go 3 plus, and then you add the displacement, okay? That's how you get the new position.